Hey, what's up, ladies and gentlemen? So, we're heading to chapter 3, which is going to be about measurements, certain measurements for data. So, we're going to be analyzing data using certain measurements. In 3.1, that's our section, we're looking at measurements of the center, measurements of centrality, you could also call it. So, we're going to have two big measurements of center that we're going to focus on in this section, and we're going to talk about, first of all, the mean, the sample mean. So mean is simply average. Average, if I can spell that word. This is probably the most common, the most popular measure of center, most common measure of center. And when we're talking about sample mean, the mean of a sample, we use the symbol X bar. X with a bar over top of it, and to calculate that, you use the formula, the sum of all your data values, X, divided by N, the sample size. So what are these symbols again? So X bar is the sample mean. This symbol means to add up, or to total or tally. Add up the X's. They represent your data value. So a single X would be a data value. So when I write that Greek letter sum, this is actually called the Greek letter capital sigma. This is capital sigma. It looks kind of like a backwards E a little bit. A little bit like a backwards E. That means add up. And it's the capital Greek letter sigma. So sigma X means add up the X's and then divide by N. N is the size of the sample size. So that would be the number of data values that you have collected. Sample size, if I can write that. All right, so there's a formula for mean. Let's see if we can do an example. Now, before we do an example, we can also talk about the median. Another popular measure of center, maybe not as popular as the mean. This is the middle number. The middle number for your data set. Data set. So 50% of your data is below this number, 50% of your data is above this number. So it's separates the upper 50% and the lower 50%. Of data. Okay. There's really not a symbol for the median. Some books use some symbols, some books use other symbols. I'm just going to use the word median. So how do you find the median? So to find it, put your numbers, put your data in ascending order. So what does ascending order means? Well, it means starting with the smallest number and going to the largest number. So put your data in ascending order and pick out the middle number. Pick out the middle number. I put that in quotation marks, the middle number. So what exactly is the middle number? Well, sometimes when you have an odd number of data values, it's really easy to pick out the middle number. But when you have an even number of data values, sometimes you have to take the two data values closest to the middle and take the average of those, find the halfway mark between those. Now let's do an example. I'm going to start with a problem. This one is about basketball players. Basketball players. So here's my problem. Example. A sample of 11 basketball players. Is selected. Okay, so we take 11 basketball players. Their heights in inches let me erase. Their heights in inches are listed below. Okay, here we go. 75, 74, 73, 72, 66, 77, 76, 78, 76, 80, and 76. Okay, so those are the heights of 11 basketball players. Part A, question, determine the average here. Determine the mean. That's called X bar, right? So let's make sure we got 11 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so the mean is X bar, right? We're going to add these dudes up, add up the X's, and divide by N, the sample size. So we're going to add up all of these. So you take 75 plus 74 plus 73 plus 72 plus 66 plus 77 plus 76 plus 78 plus 76 plus 80 plus 76. Get a calculator, do that. Let's see, what do you get? Looks like we get 823. So that's sigma x, capital sigma x, or the sum of all the x values is 823. And to that, we're going to divide 11, right? Because we have 11 data values. So if I do that, 823 divided by 11 is 74.81 repeating. Is that right? Oops, my calculator just quit on me. Let me get another calculator. Battery problems. Don't you just love battery problems? There it goes. Yeah. 74.81 repeating. Now, if I wanted to, I could just write this exactly as 81 repeating. 0.81, 81, 81. You put a bar over the 81 to indicate it's repeating. But oftentimes, we just round. So if we need to use this number here for something else, it's often convenient to round. So we'll say X bar is approximately 74.8. I'll round one more decimal place than the values from the data set. So notice the values from the data set, 75, 74, 73, 72, and so on and so forth. They go to the ones place on the right. The rightmost data value, the rightmost value is to the ones place. So we can go one more decimal place. That's generally the convention. Go one more decimal place in the original data value. So we go to the tenths place, so 74.8. Okay, so you could put 74.81, repeating that would be fine, but I'm going to round here. All right, so the next thing we want to do, part B, we want to find the median. The median, and we'll compare the mean and the median. Determine the median. Height. So the first thing you want to make sure is you want to make sure that your numbers are in ascending order. I'm going to start off with 66. It's the smallest number. And from there, I'm going to go to what would be next. I believe 72, 73, 74. And from there, I can go, what, 75, 76, 76, 76. So I'm crossing them off as I go along. The next number would be what? 77, 78, 80. And I think I got them all. Oh, I forgot to cross off that 77. It didn't cross off. Because yeah, sometimes for some reason the iPad, I touch it, doesn't cross off. Do I have all 11 numbers here? Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, I got all 11. So because we have 11 numbers, we have an odd number of numbers, we can literally just pick out the middle number. So basically you have 5 on the right, 5 on the left, and right there in the middle you have the middle number. So let's count in 5 from the right. 1, 2, 3, 4, 5. And then just to the left of that, you should have your middle number. And then let's just check on the left if we got 1, 2, 3, 4, 5 to the left of the middle number. Yeah, so here your median is going to be 76. So notice here that the mean is 74.8 approximately, and the median is 76. Notice they're not the same. So the mean and the median are not always the same. It depends on how your data is distributed. The question we want to ask is, in this case, which is a better measure of center? Is the mean or the median a better measure of center? Which is the better measure of center? Here. And then explain your answer. Okay, I'm going to scroll down just a little bit. So let's look at our data set here in blue. I've arranged it in order from the smallest to the largest. You see 66 is the smallest, 80 is the largest. And which of these do you think is a better measure of center? 74.8, the mean, or 76, the median? So which one is more in the center, 74.8 or 76? Just look at all those numbers. So I would say probably 76 represents a better measure of center. Doesn't 76 look like it's more in between, like at the halfway mark? So it turns out that median is actually the better measure of center here. Median. So what's happening is the mean is being pushed to the left. So the mean, what, 74.8 approximately, is somewhere around here, right? Somewhere around here. So it's being pulled to the left. And that's because this guy here on the end called 66, this guy 66, he has a very strong effect on the mean. That 66 has a pretty strong effect on the mean. He's an outlier. It turns out he is an outlier. That 66 is pretty far away from the other numbers. Or 66 is pretty far from 72. So it looks like all the other numbers, all the other blue numbers are spaced pretty close together next to the next one. But 66 is an outlier. It's far away from the others. So that outlier is affecting the mean quite strongly and pulling it to the left. Turns out the median does not get affected very much by outliers. So the answer is, which is the better measure of center here? And the answer is median. It is not strongly affected. By the outlier. So an outlier is a data value that's far away from the others. 66, like the mean is. All right. So we found the median, and we said it's a better measure of center because there's an outlier that would cause the mean to be not a great estimation of center. Let's do another example. Just practice. Let's focus on kindergartners, right? Kindergartners. Here we have a sample of 12. Kindergartners. Hard to spell kindergartners. That's a German word. German origin. A sample of 12 kindergartners are weighed. Their weights in pounds are listed below. Okay, so we got what, 52 pounds, 41 pounds, 36 pounds, 40 pounds, 47 pounds, 43 pounds, 46 pounds, 48 pounds, 41 pounds, 38 pounds, 42 pounds, and 50 pounds. So here we have 12 numbers. That should be a 50. Looks like a 56 maybe. Let's make sure you can see that's a 50. There are 12 different kindergartners here. So we have 12 different weights listed. So part A, we want to determine the mean. Determine the mean. So known as the average. X bar. Right, so what am I going to do? I'm going to write X bar is equal to the sum, that symbol means sum, of all the X values divided by N. So let's add up those numbers. Calculator, get that calculator working. 52 plus 41 plus 36 plus 40 plus 47 plus 43 plus 46 plus 48 plus 41 plus 38, right? Plus 42 plus 50. I get 524 when I add up all my data values, and I'm going to divide by 12, right? 12 is the sample size. It's the total number of data values. So divide by 12, and you get around 43.6 repeat. Well, exactly, 43.6666 repeating. So we're going to put a bar over that. You could write that as your answer. I'm going to actually round, though. I'm going to go one more decimal place than the actual data values themselves. So I'm going to round to 43.7. Approximately. I'm using the squiggle marks to say approximately. All right, now let's do the median. The median. So if we're doing the median, we want to put the numbers, the data values, in order. We're going to start with the 36, right? Oh, I got to write my instructions. Let's write the instructions. Determine the median. Okay, let's start with the smallest, 36. And we're going to work our way up. So what do we have? 36, 40, 41, 41. So anytime you're repeating a data value, you have to include every repetition. So if you see 41 showing up more than once, don't list it just one time. List it every time it shows up. Then what else do we have? Oh, I forgot 38. Let's go back. I totally forgot 38. So 36, 38, 40, 41, 41. That's better, right? Don't forget any numbers, otherwise you end up like me in bad shape, right? 42, 43. What else? What else? What else? Looks like 46, 47, 48. And do we have any others? Looks like we got a 50 and a 52. Is that a total of 12? Let's check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yep. So if I'm doing the median, if I have an odd number, it's easy. But what if you have an even number? Like in this case, we have a total of 12. Well, you're going to take 12 and divide it by 2. That'll give you 6, right? And you're going to count 6 from the right. 1, 2, 3, 4, 5, 6. And you're going to circle that 6th number. And then 6 from the left. 1, 2, 3, 4, 5, 6. So these are the two numbers closest to the middle within your data set. Then you're going to find what's in between these. What's the halfway mark between these? Well, you could just say, okay, what's halfway between 42 and 43? And you say 42.5. But sometimes it's not so easy to figure out what's halfway between. In this case it is, but sometimes you actually need to average those. So that's the way you would do it. You would average those two numbers. So I'm going to take 42 plus 43 divided by 2. That's what, 85 divided by 2. So that means the median is 85 divided by 2 is 42.5. So I mean, you could have thought that to yourself, right? Just thinking, hey, what's halfway between 42 and 43? Well, 42.5. Yeah. But if you had some other strange numbers like 41 and 49 were your two closest numbers, that might have been a little harder, and you would actually want to average those to figure out what's between halfway. Okay, so yeah, I think we're going to quit right there with the mean and the median. We'll do one more thing in this section in our next video.